All right, so we are going to start thinking about simulation in code, ways of representing natural systems through code. And this runs the range from kind of simple things like this wind example here. You can see running our little lollipop tree blowing in the wind, all the way to obviously like super complicated simulations that require years or decades of study and knowledge of the system that you're modeling, tons of math, things like that. We're going to start much simpler here with this wind example, which you can see, but we'll see a couple of interesting things. One is that we can model things that look really realistic or feel realistic in the context of our sketch. And also things like changing variables are really going to change the way that these systems run, these simulations are going to look. And there's something really, I think, mesmerizing and exciting about being able to create something in the computer that feels like it's from the real world, and then see how changing parameters and tying things together and mapping one thing to another really can create these complex systems with not, kind of simple code. So we're going to go ahead and create this wind example together as a starting point. So I'm going to do my setup, and let's make this 600 by 600. And then you may not have seen this before, but surface.setLocation is a really awesome kind of like a hidden setting in processing. It's not super well documented, but what it does is it changes the location where your sketch window goes. So for example, if I run this now at 0, 0, it's going to draw my window over here in the corner, which I just really like. It keeps it from popping up in the center on top of my editor window, so I can keep it separated. I have two monitors going on here, and so I can actually have it go onto the second screen in a specific location. And I don't know, this is something I always do. I think it's really helpful. So not necessary, but it's really cool. So we don't need anything else in setup. In our draw, now I'm going to keep my color scheme really monochromatic here and kind of simple, but this is one of those places where with simulation projects you can go really nuts and start like modeling color. This background's going to be a dark gray, but you could have like the sky and have kind of like a gradient going on that could change over time. Maybe it's tied to the real clock on your computer so that when it's dark out, it's dark in your sketch. I mean, so many really cool things that you could just keep building and building and building on this example. What I want to do first, before I model the wind, is I want to draw this tree. And I think it's a really good idea. These projects get complicated really quickly. Is to just verify that everything is working right step by step, instead of trying to build it all and then hope it all turns out right. So we're going to be using matrix transformations, push matrix, pop matrix, translate, and rotate, which are going to be also really key for a lot of these kinds of projects. They make the drawing commands much simpler. Instead of being relative to screen coordinates, everything is relative to 0, 0. It just makes it a lot easier to kind of keep track. And so then what I want to do, I'm drawing that little lollipop tree, and I want to draw the trunk up from the bottom and then draw this kind of circle. And so I'm going to use translate to go to the position of the bottom of the trunk. So that's going to be width divided by 2 and height. And we'll talk in a minute about why we're drawing up from the bottom rather than from the top of the trunk. And then let's draw the trunk first. So I'm just going to do this as a line. You could do it as a rectangle. And I'm going to make it kind of this dark color and a width of 5. And then this line is going to go from 0, 0, that's our new origin because of translate, up to where we want it to go. And I think it's going to be helpful for us to have a variable to control the height of that trunk. So I'm going to say float trunk len. And we're using floats here. I think, again, in simulation, we're really trying to model the natural world. Floating point numbers giving us that decimal precision allow us a lot more flexibility, so we can kind of change parameters. There's no rounding. It's going to give us much smoother output. So I'm going to use float for almost everything for these examples. So I'm going to make this 300 pixels. So now my line is going to go from 0, 0, that bottom center, to 0, negative trunk length. And it's negative because we're drawing in the up direction. Then we want to be able to draw the foliage, the like circle that represents the top of the tree. So I'm going to use an ellipse for that. I'm going to say fill, and let's make this like a nice semi-transparent white color with no stroke. And then this ellipse is going to go at 0, negative trunk length. So that's going to be, again, the top of the trunk. And let's make one more variable for this. I'm going to do float, maybe foliage diameter. And let's also make this 300. We can try changing this and see how it looks. So foliage diameter, and that's going to go in our ellipse here like that. So I'm going to run this, see if that looks correct. That looks pretty good. We could change lots of stuff already, you know, thinking about ways of making this look cooler. I think maybe that trunk could be a little thicker. That looks pretty good. But, you know, we're getting ahead of ourselves. We need to add the wind first. But you can see easily how you could kind of go down this rabbit hole of making this look cooler and cooler. So this is our simple tree. And now we need a way of changing its angle based on the wind. And to do this, I'm going to want to have a couple of variables. The first is one called wind speed, and this is going to keep track of the current wind speed that'll map to the angle. So I'm going to start that at 0. And then I need some way of telling the computer how much I want the wind to vary each frame. We're going to have this wind speed changing over time. So I'm going to call this wind increment. And we're going to make this a small number. We don't want it to be too big because then it's going to change really quickly. So I'm going to make this, let's say, 2 degrees. This is going to be measured in degrees, and we'll convert that to radians for the rotation based on the wind. So we've got those two numbers. The wind speed starts at 0, and then each frame of the animation, we want to update that. So we're going to update the wind speed. And for now, we're just going to use the built-in random generator. And we'll see in a little bit why that may not be our ideal. And we may want to change this to something that'll look a little bit better. But for now, random is pretty easy. And we're going to do this between negative wind increment and positive wind increment. So now the wind speed is going to vary left or right by that amount. And then we're going to need to turn this into an angle of rotation. So I'm going to say float angle equals radians wind speed. And then we can pop that down here, rotate angle. So we can see our tree bending in the wind, bending further and further and further. But there's a couple of problems. One is that the motion is really jerky. The random number generator is just sort of like bouncing around. It's not giving us a very smooth sort of transition like we would expect from a natural system. And we can see that eventually these numbers are not sort of like limited in any way. They might go all the way, you know, the tree might bend so far that it touches the ground or even goes below the ground, which is not going to look very natural. So I think what we want to do here is update the wind speed, but then constrain it to a certain range of values. And we can use the constrain function for that. So I can say wind speed equals, so after I've updated, I can say wind speed equals constrain wind speed. So that's the number that's going in. And then constrain lets us say what's the minimum and what's the maximum this can be. And so maybe I want this to be between negative 90 degrees and 90 degrees. That would be bending all the way over. So actually, maybe that's not quite what I want. Let's do negative 45 and 45. So that means the tree could bend like this or like this, but never past that. Now, if we run this, we can see, we should see, it's never going to get past that point. If it ever hits that, like say it goes to 45, then it's going to stop at 45 and it's just going to kind of stay in that spot until it works its way back. We could also decide maybe we don't want the wind to blow in both directions. We only want it to go one way. And in that case, we could constrain it between 0, straight up and down, and 45, or maybe it could blow a little bit that way. Again, this is where you could start really playing and finding cool, you could just keep changing settings and trying things. And I've spent hours and hours doing this. It's always really fun. So this looks better. We're going to avoid it going too far. Now you also notice that we're working in degrees here. You could work in radians if you wanted. You could make the wind increment not in degrees but in radians and not have to do that conversion. I think most people are more comfortable with degrees. Obviously, there is this conversion that has to happen in a really complex system. Maybe that's somewhere that you want to optimize where you're just straight in radians. I think for now this makes it a little bit more readable. So then the other thing that I think what we probably want to change is this jerky motion, and there's probably other ways to do this, but I think the one that makes the most sense is to use Perlin noise. And we've talked about Perlin noise in the past, looking at ways of generating random numbers, and Perlin noise is a really cool one. It's much harder to kind of get your mind around it, and I recommend taking a look at the examples from Creative Programming 1 to see how to use Perlin noise or the built-in examples in processing. But Perlin noise is really cool. It was created by Ken Perlin in 1983. He won an Academy Award for that, which is really amazing for this algorithm that basically generates randomness that is not so jerky, but has this kind of like flow, or it feels much more naturalistic. And Perlin noise can be done in 1 dimension, so to create this kind of like back and forth motion, 2 dimensions, which can be used for these kinds of images you're seeing here, or even 3 dimensions, which will give you sort of like cloud shapes and stuff like that. Perlin noise is used for a lot of things, including terrain generation, so that basically you create this black and white, this is a good example here, you create a black and white image that maybe the light color maps to the highest and the black maps to the lowest, and then grayscale is in between, and then you can use that to sort of create this terrain-like surface. It's really cool, and it can make very natural looking sort of landforms, Minecraft, things like that. Perlin noise is also used in special effects and has been for decades for things like smoke and explosions, where you can create these like really cool things from Perlin noise, or then using that as the starting point, you can do manipulations to the numbers that you get to create all kinds of other sorts of shapes. So for Perlin noise, we need to, basically you have this like noise function that you give it a number and it sends back sort of the next value in the algorithm, and then you update and continuously update, and you get these new values back that will give you this much more even kind of motion. It'll be jerky, and then it'll be smooth, and it'll feel much more naturalistic. And to do that, then we need another variable, and that's going to be our noise position. And we can start this at 0. You could really start it anywhere. We'll see for our example, it doesn't make a difference. In some of the other examples that'll be later in this playlist, we will actually be using multiple noise positions so that the behavior is not exactly the same. I mean, I should say Perlin noise is a deterministic system in the same way that the random number generator in processing is. So if you give it a noise position of 0, you're always going to get the same number back. Okay, so we've got that. And then down in our code here, we're going to keep this. I'm just going to comment out this will be our wind speed using random, but instead we can do this now through Perlin noise, update wind speed. So instead of asking for a random number using the random function, we're going to say wind speed equals noise position. So in this case, it's 1-dimensional noise because we're just going back and forth. And noise is going to give us a number between 0 and 1. So that's not going to be very useful for us here. I'm then going to multiply this by a number, in this case 45. So that's going to give us a range of angle between 0 and 45 degrees. And we could change this. We could use map to have it go in a different sort of like amount. And then, so it's going to give us our angle in degrees. So then down here, we need to change this to be radians. So we're rotating by that, not by degrees, because rotate expects an angle in radians. And then every frame, we need to update this position in the noise function, because otherwise we're going to get that same number over and over. So I'm going to say noise position plus equals, and this is where then we would use wind increment. And we're going to see that a wind increment of 2. So right now, before that was in degrees because it was our random number generator. But now this is actually going to be our, maybe we should rename this actually to be noise increment. I think that makes a little bit more sense. Our noise increment of 2 is going to be really kind of a lot. So I think a good place to start is 0.01. And we can try changing this, and you'll see that changing that value is going to change how quickly the tree moves and how smoothly it moves. So let's try running this, and let's see, we've already made a mistake. Aha, so angle no longer exists, but we can just say wind speed now. There we go, a huge difference, right? Like we're seeing the motion is not so herky-jerky as it was before, but it's actually, you know, really variable. It feels much more naturalistic, and this is why Ken Perlin won an Academy Award for his algorithm. Like it really works amazing. It's not taxing for the computer, and the results are like really spectacular. So Perlin Noise takes some getting used to, kind of to get your brain around it. But once you get it working, it's kind of amazing. So we have our tree blowing, and we could change some more stuff here. For example, we could change we could try changing our angle. Instead of just being between 0 and 45, we could use map with noise as our input. That's going to be between 0 and 1. Maybe we want to go between -10 so we can blow back a little bit. To 30, we can try that. And so you may not see it go back the other direction, but now it's going to go between 30 degrees and -10. You could also map some of these values to the mouse coordinates so that you could kind of have it be interactive where you're changing the wind speed. This is pretty cool. Let's try adding one more thing, and then I'll show you kind of a fancy version, a different way of drawing the tree. Obviously, you could spend more time kind of making this tree look a lot cooler than it does now. You could even draw this tree in Illustrator or cut it out in Photoshop and apply that. You could do lots of really cool things that way. So the tree on its own kind of doesn't feel like it's really, you know, blowing. I mean, it feels like it's blowing in the wind, but it would be nice to see other things affected by it as well. So let's maybe do 2 other things. We can, so we've got our wind speed value here, which is really helpful. Let's draw some grass on the ground. So this is our simple tree. And for our grass, let's just do it evenly spaced. I think that's a little bit easier. We'll see in a little bit how you could build, you know, an object-oriented approach to this where you have many trees and many blades of grass and they all have different values and it would get really cool. But to keep it simple here, let's just use a for loop. We'll start x at 0. X is less than width. X plus equals, I don't know, let's space by 3. We can try that. So basically, we're going to walk across the bottom of the screen and draw all these blades of grass that'll get blown by the wind. So then we're going to say push matrix again. Pop matrix. Translate. And I always like to, I don't know, maybe this isn't necessary, but I always like to use or to add the pop matrix right away. So I keep track of where it is. It can be easy if you're nesting these to sort of like lose track. So we want to translate to x and height because we're going to draw it up from the bottom. And we're going to rotate again by radians wind speed. And we could try varying this a little bit. Maybe the grass blows slightly more or slightly less than the tree. Lots where we could play around there. But let's just start with this. And then I can say stroke. Let's do white. Stroke weight, we don't want to be as thick as the tree trunk, so maybe we'll make that 2. Again, we'll just try this and see how it looks. And then a line between 0, 0, and 0, and we could create a variable for this, but let's just say -10 for now and see how that looks. And cool, they're maybe a little too short to see. Let's try making those a little longer and maybe spacing them out a little bit more. Cool. So, you know, not super realistic yet because they're all blowing together. They're all exactly the same length. We could try, and they're blowing with the tree. So everything kind of just seems maybe a little too tied together. So let's, instead of mapping this here, let's just leave wind speed at noise. So we're going to have a variable between 0 and 1 that'll be globally accessible for my sketch. And then here we can say float tree angle equals map wind speed. That'll be between 0 and 1 because that's directly out of our noise function. And then we wanted to go, I think it was -10 and 30. And then instead of wind speed here, we can say tree angle. And what this will let us do is separately create kind of a rotation for the tree and for the grass. So maybe here it's between -10 and 30, but for our grass, instead of tree angle, we can say grass angle. Maybe we want to go between I don't know, -15 and -50. We could just try this and see how it looks. And then instead of wind speed here as well, this will be grass angle. So now, because the grass is a lot thinner, it's going to be blown by the wind more than a tree. You know, maybe even this tree is blowing too much. We can try making it a lot less. And again, you know, this is where you start to really play with these settings and see all the really cool things that happen as you start to experiment. There's lots more we might want to vary here. You know, maybe each blade of grass gets a kind of a random offset. You can try that here. Maybe between negative, this is going to get a little sloppy looking because we're in radians, but between -3 degrees and radians 3 degrees. So that's going to offset them randomly. Now we're going to see in a sec, because random uses the current system clock. That's how it generates that number. That's its starting point. Every frame, it's going to do kind of this. So we can, this is actually another really useful thing for simulations. We can say random seed and give it a specific number. And that overrides the it using the clock. And because we're doing it every frame, now if you did it up in the setup, it would mean every time you run your sketch, it looks the same. But doing it every frame resets that so that you get the same kind of results. And oops, what did I do? Actually, so this is a little messy here. We can change this to be a little easier. Because grass angle is already degrees, we can say plus random -3, 3. That's a little easier to read. And we're already converting that to radians inside there. Let's see. Cool. So now we can see every blade of grass is going to be a little different already. You know, this looks so much more kind of realistic. Obviously the height. Okay, well, we're already doing it. Let's just go ahead. This is our blade length. Let's do negative random. Let's do between negative, I don't know, 20 and, well, this biggest number would be 40 and -20. That's maybe a little too much. Still too much. Oh, duh. -30 and -20. That'll be better. There we go. So now they're varyingly height and slightly varying how they're receiving the wind, which is cool. And again, the reason this looks right, if I was to comment out this random seed, you're going to see they're doing this kind of thing, which is not what we're after. And that's because the random number here and number here are different every single frame. If we were to use a class for this, like a grass class that had a built-in angle, offset, and height, that would solve some of this. But for now, by just having the random seed the same every frame, we get this kind of cool result here. So, I mean, I could spend another bunch of hours, and I promise you I have before, like continuing to add to this. We could add clouds that blow across at a different rate. We could have like little leaves that blow. You could start to go really nuts on this. I want to show you one other version of this. So this is kind of the pre-built version that's online. And actually, so this is commented out, but so that was our simple tree, but we can also draw what's called a Pythagoras tree. And this is a, let's see, I think that's going to be a little too high. Sorry. There we go. Make that just a little shorter. Cool. So the Pythagoras tree is a really classic fractal pattern that is also really simple to draw, at least in code in the draw loop here. Basically, we draw the trunk and then it branches. And this uses a process called recursion, which we've talked about before. And I definitely recommend recursion is another thing that's really hard to get your mind around, kind of like Perlin Noise. So I recommend taking a look at some of the examples from processing. But basically what happens is it draws a line and then it splits and it shortens that line and draws another line. And then it splits again and again and again. And then it kind of like follows this path like this until it reaches a minimum length, and then it pops back and draws. And anyway, it's a way of creating this like really complex kind of pattern here. And already, obviously this looks much more natural like a tree. And you can see how we have it kind of like blowing in the wind. And I've got some other variables here like twist that let us change the stiffness of larger branches so that you can see here the trunk doesn't blow, but the upper branches do. Things like that can be really cool. Obviously the code here is more complicated, and I think we can get a lot just from, and this is the two side by side, even though the graphics for this example we did together aren't super complicated, you're building a world. And just like in cartoons where you can have really simple visual language that creates a really immersive experience and a believable story, I believe that this is a tree with this circle on it, even though it's not really, super accurate. And you could use really simple shapes or illustrations or stuff all generated in code. It's kind of up to you how far you want to take that. So this idea of modeling a simple behavior and changing something based on that, we're going to see throughout the next bunch of examples that we're doing together.